In this video, we introduce some built-in commands. What you see is a downloaded version of Mathematica, but what I do here will work with wolframcloud as well. This is an example of entering some arithmetic expressions. Make sure to use parentheses for grouping terms. And do not use brackets when there are multiple parentheses. Also notice that the multiplication symbol can be omitted. This is another example of multiplication. Notice that there is a space in between A and B. If you type A and B with no space in between, it will recognize it as one variable, with name AB. This is how to enter exponential expressions. When the exponent is 1/2, it is equivalent to the square root. Mathematica converts the 1/2 power of 3 to root 3. If a numerical base is used, it converts to a numerical result. It also has the built-in command sqrt for square root. Notice that we use brackets for this command, since it is a built-in command. However, in the above exponential expressions, there isn't any command used, so we use parentheses. E is an important base of exponential expressions, and you must use a capital. Also distinguish that E is not a command, but it is a built-in constant. To get a numerical value, use the n command. Here I added an option, so it displays more digits. Now we are going to introduce more built-in Mathematica commands, and remember, the first letters of the built-in Mathematica commands are all capitalized. The natural log is just log, which is probably different from your calculator. Also remember, the arguments of Mathematica commands are surrounded by brackets, not parentheses. The log function with base 10 can be computed by inserting the base, as in the example. These are trigonometric functions. By default, the arguments 1, 2, and 3 are recognized as radian measures. Probably we want numerical values, and we use the n command for that. You can also use numerical arguments to invoke numerical results. It is not as precise as the n command, but very convenient. If you want to use the degree measure in trigonometric functions, use the built-in constant, degree with capital D, as in the example. An angle of 60 degrees is one of the special angles, for which we know exact values. But for an angle of 70 degrees, exact trigonometric values are not available, and Mathematica uses its own standard method of treating such values. I used a numerical argument, and it computed a numerical value. The inverses of trigonometric functions use the prefix arc. Notice that A and S are capitalized, and I used a numerical argument to get a numerical answer. This is the well-known quadratic formula. And let us use it to compute solutions of a quadratic equation. I picked a quadratic equation, and named the coefficients a, b, and c. If you use semicolons, you may enter those short codes in one line, as shown here. Since the quadratic formula is describing two solutions, I separated them into two lines. The command, sqrt, is a command, so I used brackets. But for other parts, I used parentheses. Also notice that there is a space in between a and c, and that 2 times a in the denominator is surrounded by parentheses. Otherwise, Mathematica will think only 2 belongs to the denominator, and a belongs to the numerator. One easy way to deal only with numerical results is to use numerical values for a, b, and c. I re-entered them as numerical values, and executed both cells. To obtain these numerical values, if you want more precision, use the n command. When you define a, b, and c, notice that I switched the first arguments of the n command to exact values, with no decimal points. For example, if you use 2 point instead of 2, for constant a, it will ignore the 20-digit precision, and just use the default precision.